Hello, second, seventh, and eighth period algebra students. Mr. Lawrence here, and it's kind of late. It's 11:05. I've been working too much today, but I tell you, I had some fun watching some of you girls play volleyball. Good job, Aaron. I really enjoyed the game, and Madeline, I saw you out there, and of course, there were a lot of other out there, and I saw some of you at the game cheering on your teammates. I thought that was really cool. And I want to give a special shout out to Madison Fiorito. Yeah, Madison, I love having you in class. Make sure you keep doing your best. All right, let's get down to this. Today we're going to be solving inequalities, and I know you've seen a video on this, but we're going to get a little more in depth with it. We're going to start doing something with it real soon. Quarter's almost over. We're going to be having a test soon. Anyway, we're going to solve inequalities. They're going to be done very much like solving equations. It's going to be a little bit different. And you notice the types of problems I have look very similar to the types of problems you've been doing recently. Difference is there's a special rule when I multiply or divide by a negative. That's weird. Anyway, and I'll talk about that in a minute. We're going to have to do that. And then also, I'm going to present my answer a little bit different. I'll present it in 3 ways, and so I'll model that for you. Make sure you're doing that. Kevin Merrick, are you listening? Do everything I'm asking you to do. All right. So number 1 says 5 minus 3x is less than 17. Well, this is just a simple 2-step inequality. What's my goal? To get x alone. What's keeping x from being alone? The 5, which is positive, and the negative 3, which is being multiplied by x. So I'm going to get rid of the 5 first by subtracting 5 from both sides. And then that's going to cancel. I get negative 3x is less than 12. And then I'm going to divide by negative 3. And this is very, very important. Put big stars by this. Highlight this. Whenever you multiply or divide by a negative, the inequality changes direction. Now, it's only when you do it to both sides. So I've got to be careful how I say that. When I multiply both sides by a negative or divide both sides of the inequality by a negative, then the inequality changes direction. The less than became a greater than. Did you see that right there? Did you see it? Okay, there is my solution in a mathematical sentence. My solution in a solution set, I make this little kind of curvy guy called a brace. And I say that x can be any real number. See how I'm writing that? X is any real number such that bar means such that x is greater than negative 4, and then I close my brace. Okay, so this is called set notation. It's describing the set of solutions. Remember, we've talked about the number line and how there are more numbers on the number line than there are stars in the entire universe. Okay, well, there's an awful lot of numbers that could make this inequality true. And here's how we describe them. X is any of the real numbers such that x is greater than negative 4. Now, on a number line, the solution is going to look like this. I have to show the negative 4. I have to. Negative 3 would be to the right. Negative 5 would be to the left. And since the inequality does not have an equals to it, I put an open point at negative 4. Now I'm going to test. X is greater than negative 4. I'm going to leave that blank. Fill in a number for x. Pick an obvious number like 2. 2 is greater than negative 4. Or is 2 on this number line? It's to the right. So I'm going to shade to the right. Pretty simple stuff. All right, let's see here. Here, number 2, I have x's on both sides. Some of you want to take care of the 4 or the 6 first. I won't. I like to get rid of the x terms. I'm going to subtract 8x from both sides. When I do that, I end up with 2x minus 4 is greater than or equal to 6. Now it's just a 2-step inequality. I'm going to add 4 to both sides. I'm going to get 2x greater than 10. Now I'm going to divide by 2. Is the inequality going to change direction? What's that, Sam? No, of course not. Why not? Because I did not multiply or divide by a negative on both sides. See, in this example here, when we get a highlighter out, in this example here, we divided by negative 3 on both sides of the inequality. That's why the alligator changed directions. Okay, so on this right-hand side, we got x is greater than or equal to 5. Oh, I should have done my solution set first before the number line. So I start my brace, and I'm going to get x is any real number such that x is greater than or equal to 5. All right, so I'm going to put 5 on the number line. I have to because it's in the solution set right there. 6 there, 4 there. Since it's equal to, I will put a closed point there. Now I need a blank is greater than or equal to 5. Put in a number. How about 6 is greater than or equal to 5? So I'll shade toward the 6. Had I put 4 in, I would have gotten a false statement, and notice 4 is not shaded. All right, this one here, very similar. I'm going to multiply to get rid of the fractions. I think I'm going to multiply by 12 over 1. And I'm going to multiply by 12 over 1 and by a 12 over here. So 4 is going to go into 12 3 times. That's going to be 3x. Minus 3 is going to go into 12 4 times. That's going to be a 4x. And that's going to be greater than or equal to 24. Notice the inequality did not flip yet. It's going to flip in a minute, but not yet, because I multiplied by 12, not by a negative 12. Had I multiplied through by negative 12, it would have changed direction. All right, here I'm going to combine like terms and get a negative 1x greater than or equal to 24. And then I'm going to divide by negative 1 on both sides. So x is going to be less than or equal to negative 24. The solution set would be the set. So x is any real number such that x is less than or equal to negative 24. And I'm going to close the brace. All right, I'm going to draw my number line. And I'm going to get a negative 25, a negative 24, a negative 23. I need a closed point at negative 24 because it's equal to, and I'm going to fill in the blank. Give me a number that's less than negative 24. How about negative 100? That would be this way, wouldn't it? So I will shade in that direction. Okay, one last problem, and then it's time for the quiz questions, which are real simple. Don't like this 2. It's attached by division. I'm going to multiply by 2. Multiply by 2. Inequality does not flip because I didn't multiply by a negative on both sides. All right, here there's nothing left to distribute. I'll have 5 minus 3x. I'm going to subtract 5, subtract 5. I'll be left with a negative 3x is less than or equal to 11. I'm going to divide by negative 3 on both sides, which caused the inequality flip. We're going to get x is greater than or equal to negative 3 and 2/3. Solution set would be x is any real number such that x is greater than or equal to negative 3 and 2/3. Number line, well, I'm going to show negative 4, negative 3, then negative 3 and 2/3 would be up right about there. It will be a closed point. Why? Because it's equal to. See the equals? Less than or equal to. All right, now fill in the blank. Blank is greater than or equal to negative 3 and 2/3. Give me a number greater than that. How about 5? 5 is greater than negative 3 and 2/3. I'm going to shade in the direction of 5. And there you go. Okay, here comes your 2 quiz questions. Actually, technically, I guess it's 3. First one is, when do you change the inequality from less than to greater than? Or you could have said from greater than or less than. Or you could have put the equals in there. And number 2 is, when is the point open on a number line? And part B of it is, when is the point closed on a number line? All right, that's your video. There's your little 2-point quiz. Mr. Lawrence signing off. Have a good night, everybody.